Today, we're pulling back the curtain on the invisible rules that, well, kind of run our entire digital world. We're talking about the deep-down logic inside every single piece of software, from that game on your phone to the most complex systems that power our economy. So let's dive in and figure out why this hidden code is the difference between a great experience and a total digital meltdown.
You know the feeling, right? We've all been there. You're trying to get something done, and bam, the app just crashes, or it spits out some bizarre error that makes no sense. It's so frustrating. But what if I told you that the difference between that seamless app and the one that drives you crazy often just comes down to 3 basic moves?
And the stakes here? They can be incredibly high. We're talking about flawed logic that has forced travelers into quarantine by mistake. It's caused a trading algorithm to literally lose almost $500 million in less than an hour. And yet that very same logic, when it's done right, can perfectly power something as simple as a camera that knows exactly when a bird has flown into its little nest box.
The secret to understanding all of this, the good, the bad, and the just plain catastrophic, is really getting your head around 3 key ideas: sequence, selection, and iteration. These are the core building blocks of what we call control flow. They're the instructions that tell a computer what to do, what order to do it in, and crucially, when to stop. Once you see these, you start to see the code behind everything.
All right, let's start with the most straightforward of the 3. Sequence. This is the absolute foundation of every single program. It's really just the art of doing things in the right order. Think of it like a recipe. An algorithm is just a plan, a set of instructions. And for that recipe to work, the computer has to follow each step exactly as written, one after the other. If you get the order wrong, you're not going to get the cake you were hoping for. It sounds simple, but it is absolutely critical.
And this just illustrates the point perfectly. You can't open the door before you unlock it, right? You can't switch on the light before you're even in the room. Each action depends on the one that came right before it. This linear, step-by-step process, well, that's the essence of sequence. But of course, the real world isn't always so simple. Programs have to be a little smarter than just following a to-do list. They need to be able to react to new information, to make decisions. And that brings us to our second move, selection.
So, selection is all about asking questions. It's how a program chooses which path to go down. Is the door locked? Is the room dark? Based on the answer, the program decides what to do next. This is exactly what makes software feel intelligent and responsive.
And programmers have a couple of main tools for these choices. For a simple yes or no question, like, is the door locked, they use what's called an if-then-else statement. It's super direct, very efficient. But what if a program is handling, say, a shipping status? It could be processing, shipped, in transit, or delivered. Instead of a messy chain of ifs, they use a much cleaner structure called a case or switch statement. It just neatly organizes all the possibilities, which is absolutely key to writing code that's easy to read and way less likely to have errors.
And here is just a perfect example of that simple if-then logic working beautifully. The Springwatch team just needed to know if a bird was entering or leaving its nest, so they used a simple selection. If the outside sensor breaks and then the inside sensor breaks, the program knew for sure that the bird was flying in. It's elegant, it's simple, and it's totally effective.
But what happens when that same selection logic goes wrong? Well, you get something like the ArriveCAN app glitch, where thousands and thousands of travelers were wrongly told to quarantine. This wasn't just a bug in one little line of code, it was a fundamental failure in the logical flow of decisions.
Okay, so here's the thing. This was preventable. With stronger selection logic, the system could have validated inputs to catch bad data right at the start. It could have used that clean case logic to handle all the different traveler statuses instead of some tangled mess of if statements. And it could have used a really simple technique called a guard clause. Think of it like a bouncer for your code. If critical information is missing, the guard clause just stops the process right there and tells the user, which prevents bad data from causing chaos down the line. These aren't fancy tricks, they're programming fundamentals.
All right, let's move on to our third and final principle, and you'll see how this all builds. See, beyond just following a list and making choices, the real power of computers is their ability to do tasks over and over and over again at incredible speeds. This is iteration. Iteration, or what we usually call looping, is how programs automate all that repetitive work. And there are 2 main flavors. You've got count-controlled loops, which repeat a set number of times, do this 100 times. And then there are condition-controlled loops, which keep going until a specific goal is met, like keep stirring until the sauce is thick.
And iteration is not just for simple stuff. Zoologist Bill Sellers uses it to model how dinosaurs actually moved. His program runs a loop for every 10-millisecond slice of time, calculating all the forces and movements. And inside that loop, a selection is checking a condition. Has the dinosaur fallen over? If the answer is yes, the loop stops. It's this brilliant combination of both iteration and selection working together.
Now, when we're talking about these condition-controlled loops, the details really matter. A while loop checks its condition right at the beginning, so if that condition isn't met from the start, the loop might never run, not even once. But do while and repeat until loops, they check their condition at the end, which guarantees the code inside will run at least one time. Knowing which one of these to use is so crucial for avoiding some really unexpected bugs. And when we talk about bugs in loops, the consequences can be just staggering. $440 million. That is how much the trading firm Knight Capital lost in just 45 minutes back in 2012.
And the cause? It was a textbook failure of iteration. An old, unused piece of trading code got accidentally switched on. It was a condition-controlled loop that just ran wild, executing millions and millions of trades without any of the proper checks to tell it to stop. It was like a digital monster they couldn't control.
But here's the thing, this catastrophic failure was also totally preventable. Well-designed systems have kill switches to just halt a process if something looks wrong. They build in timeouts and iteration limits so a loop can't just run on forever. And, so importantly, they practice good code hygiene, reviewing and removing old dead code so it can't be accidentally brought back to life.
Okay, so we've covered the theory, we've seen the successes, and we've looked at the spectacular failures. But why does a deep understanding of sequence selection and iteration actually matter for you? Well, who needs to know this? If you're a junior developer, this is how you build features that actually work. If you're a quality assurance analyst, this is how you hunt for bugs by tracing the logic. If you're a data technician, this is how you write scripts to process huge data sets. This isn't just theory, it's the foundational skill for reading, writing, and debugging code in the real world.
Because at the end of the day, this is really what it's all about. A solid grasp of control flow is the difference between writing code that just sort of works on your machine and shipping professional-grade features that are robust, reliable, and don't break the second they hit the real world.
So I'll leave you with this question. Think about a simple process in your own life, maybe your budget, or a workout plan, or how you study. How would you break it down into a sequence of steps? Where would you need to make decisions with selection? And what parts would you automate with iteration? Once you start seeing the world this way, you'll see the logic that controls pretty much everything. Thanks for watching.